All right, Math 8, we're going to go over the substitution method for solving systems of equations. Even though this one is set up nice and neat for us to graph, graphing is not always the most convenient or the best way to find your answers. And like for a problem like this that you may get on a test, it may not give you a graph, and making a hand graph or drawing one yourself sometimes will lead to mistakes with the ordered pair that you get for the solution. Now, usually when you're going to do a substitution problem, you want to find one of the variables is isolated. In this case, it's already written in slope-intercept form, y equals mx plus b. Both of them are. Honestly, if you were given a choice to solve this one, my choice would probably be to use the graphing method. But being that we are working with the substitution method, I'm going to take this chunk of this problem right here, and I am going to substitute this chunk in for this y in this problem. Now, it doesn't matter which one you work with when it's done both of these. You could have done this chunk into here or this chunk into there. It really doesn't matter. This box turns into what's in here. So this turns into x minus 2. Okay, the equal sign comes down, and it equals 4x plus 1. We now have turned this 2 equation problem into variables on both sides, an equation where you just have to isolate the x and solve for x. Okay, so easy way to do it is subtract the 1x minus 1x. This turns into 3x. Then let's bring the positive and negative 1 over. That's gone. Minus 1. And that makes negative 3. So 3 times x is negative 3. Divide by 3. And your answer should be x is equal to negative 1. X equals negative 1. That's all well and good, but that's only part of the solution that we've got to find. We know that x is negative 1. We've got to find y. How do we do that? Take your negative 1, substitute it into either of your original 2 problems. You have to make the decision. Is the top one easier or is the bottom one easier? Honestly, it doesn't matter. They both should work if you did it right, but I'm going to choose the top one because it's going to be less work. I take the negative 1, I put it in for the x up here because that's what I found out. X equals negative 1. So change this into a negative 1. Negative 1 minus 1, y is equal to negative 3. That's what it's telling us. How do we know for sure that worked? Well, one more chance. Take our ordered pair, substitute it into the other problem. Change the x into the negative 1, change the y into negative 3. Does it work out? 4 times negative 1 is negative 4, plus 1, it does equal negative 3. Yippity skippity, our solution to these 2 equations is negative 1, negative 3. That is the ordered pair. Now, they throw a monkey wrench at you in number 2. Number 2, you don't have a variable that's isolated. There isn't one all by itself. There's all this stuff that's up there. I will tell you right now, and I'm going to get you started with this one. You've got to start being able to look at the problem and know what's going to be better to isolate. In this problem, the least amount of work for me, because you know and I know I'm lazy, is going to be to isolate the x in the bottom equation, to move the y to the other side with that negative 3. Why is that the case? Because if I move the y in the top one, I don't isolate the x. It's still got a 2 out in front of it. If I move the 2x to the other side, I still have that silly negative out in front of the y. In the bottom one, if I move the x to the other side, I don't like that negative sign up in front of the y in the top problem. So let's look at it. I'm going to isolate, first off, step 1 is going to be isolating the x in the bottom problem. So x minus y is equal to negative 3. I've got to x plus y is equal to negative 3. I've got to subtract the y from both sides. And it's going to be x is equal to negative 3 minus, stop and slow down. It's going to be negative y minus 3. Here we go. I'm going to isolate the x in this problem. I'm going to move the y to the other side. It turns into a negative y minus 3 because the negative 3 just comes down. Look at what I've done. I've isolated the variable x. It's telling me x is actually negative y minus 3. So whatever x is actually just Whatever y is, minus 3. Okay? Now, I have to take that chunk and substitute it in for the x in the top problem. So the x changes into negative y minus 3 in this one. 2 times the quantity of x minus y is equal to 6. Okay, so all I did was change the x value in the original one, 2x minus y equals 6. I changed the x into what it told me x was. X is this, negative y minus 3. Now substitute the 2. 2 times negative y is negative 2y. 2 times negative 3 is negative 6. Bring down the minus y is equal to 6. Okay, now it's just a two-step equation. Combine the y's, it makes a negative 3y, negative 2 and a negative 1, and a negative 6 is equal to 6. Add 6, and negative 3y is equal to 12. Divide by negative 3, and we should get y is equal to 12 divided by negative 3 is a negative 4. That's mostly done. We still don't know what x is. We know that y is negative 4, but we can go right into this problem here. I'll go right into this. If I know that y is negative 4, a negative 4 turns into 4. 4 minus 3 is 1. 4 minus 3 is 1. Okay, so it's telling me x is 1. Let's test. Let's go to our original problem of 2x minus y is equal to 6. I changed the x instead of this. I'm going to change it into what it tells me is 1. I'm going to change the y, which is negative y, put a negative 4 in there, so it's a negative 4. What's 2 times 1? 2. What's a negative 4? A positive 4. What's 2 plus 4? 6. Yay! It worked. It worked. So the ordered pair is 1, negative 4. Now, what I'm going to assign you from this worksheet are numbers 1, 2, 3, and then I'd like you to try number 4. Try number 4. Don't do it by graphing. It's already nice. It's already substituted a negative. It's already got the y ready to substitute in there. So do numbers 1 through 4. Try them out. See how you can do with them. Work on them. I didn't need to show you that much of number 2, but it's going to lend itself very nicely. You'll have to make a decision on number 3, which one you want to isolate. There's a bunch of them that you can choose in there. There's one that's very easy in number 3, but that's going to be your homework. Okay, so your homework for tonight is going to be numbers 1 through 4. I'll talk to you later. Bye.